And then we have question 2, another electrolysis question. A student carries out the electrolysis of aqueous potassium iodide. Okay, aqueous potassium iodide. Let's try to list all species present. Really cannot draw a line with this pen. Okay, aqueous means H2O is present, and I think unfortunately some people miss that fact. Potassium iodide is an ionic compound, so I have K plus and I minus. All right, state the half equations for the reaction that occurs at each electrode. So we're going to look at cathode and we're going to look at anode. And I think it was quite disappointing that some people still drew, wrote the equation for reduction, even though they label it the anode and vice versa. That was quite disappointing. At this level, I would expect you to be able to tell that reduction happened at the cathode and oxidation at the anodes, and that you didn't mix that up. But anyway, that did not happen for some of you, unfortunately. So I'm gonna label everything, highlight everything present. I have potassium ions and water, and then on this side, what did I do? Okay, is it iodide? Yep, so I think I need to, let's just redo that again. So we have iodide. No, we don't want all that, we just want iodide. And if you want to label both of the water, that is fine, but you still need to consider the strongest reducing agent present. And then I'm gonna try to do this side again. So I have K plus and H2O. So at the cathode, which is reduction, and we'll have to consider the oxidizing agent, the strongest oxidizing agent present is H2O. So what happened at the cathode is going to be, and you literally can just copy that equation in, plus 2 electrons going to H2 gas and OH minus AQ2. Okay. That's the equation at the cathode. And at the anode, the strongest reducing agent present is iodide ion. So this is going to go back to produce iodine and electrons. So once again, all you need to do is to copy the equation. I think that's supposed to be solid. Okay, I'm going to go with solid. And 2 electrons. Okay. So that's the first part. Now this second part, a lot of people got wrong. Suggest what would happen if the cathode was changed to copper. Now what is supposed to happen at the cathode is reduction. Red cat, reduction happened at the cathode. So you have to consider what copper is and whether it has any chance of competing with anything if it is the cathode. So if I highlight copper, copper is, where is copper? Copper's here. All right, copper's here. So copper is a reducing agent, and a reducing agent undergoes oxidation, and oxidation happens at the anode. So if copper is present at the anode, it can compete with iodide ions. However, if copper is the cathode, it cannot undergo oxidation at all because electrons are being pumped into the cathode during electrolysis. There is no way this copper can in any way donate electrons or lose electrons. So if copper is the cathode, it cannot compete with other reducing agents. So nothing will happen. What would happen? Nothing will happen. And some people got the mark because they identify that. I'm not entirely sure how you could do that though. Nothing would happen. You need to consider whether the change, whatever species, whatever new species is present, has access to the electrode that it needs in order to undergo the correct process, whether that is reduction or oxidation. So if you have a reducing agent present, it needs to have access to the anode before it can compete with anything. This reducing agent does not have access to the anode at all because it is the cathode. So nothing would happen since copper is the cathode. I mean, obviously, I'm not going to ask the same question twice. I already asked you what would happen if you replace the anode with iron in the previous question. There is no way I'm going to ask you to do the same thing twice. So if you see it a second time, hopefully that would be a hint that I'm trying to ask you to do something else, because I only have 60 marks to assess a lot of content. I'm not going to waste it on the same thing multiple times. And they generally don't do that in the exam. So be smart about that as well. Since copper is the cathode and cannot compete, or you can also say that it cannot undergo oxidation, compete with other reducing agent present. And that's 2 mark. Unfortunately, people didn't do too well. Consider whether it's the cathode and the anode. Next part, 3 electrolytic cells were set up in series as shown below. All of the solutions has a concentration of 1. That's handy, hopefully. So you have cell 1, cell 2, and cell 3, and we have that. Okay, determine the mass of copper produced at one of the electrodes in cell 2 if the inert electrode in cell 1 increased in mass by 0.34 grams. Assume no side reactions occur. Now, this is a Faraday's law question. You have a mass of something, you need to find the mass of something else. If you have 3 cells in series, the main thing that you can safely assume is that you definitely will have the same amount of electrons. So I need to determine what is going to happen at the cathode of this cell, because when the inert increase by mass, I need to know what is being produced in cell 1. So if you want to know that, you need to work out the half equations of cell 1. So cell 1 has tin as the anode. It has an inert electrode as the cathode, and in the solution we have Ag plus, SO4, 2 minus, and H2O. Okay, I am going to determine the reactions by highlighting my electrochemical series. So can I make it any bigger? Let's try 50. Okay. Hopefully you can see. I do want the whole thing on the screen though. So, okay, what do we have? We have tin, solid tin. We have tin. We have water. I'm not even going to bother highlighting the other water. We also have water here, and we have silver ions, and we consider sulfate to be a spectator. So the strongest oxidizing agent is Ag+, and the strongest reducing agent is Sn. Now this is a very interesting situation here. You can assume that there may be a spontaneous reaction between Ag+ and Sn, but that is not going to increase the mass of the electrode. And the questions say that the inert electrode in cell 1 increases by 0.34 grams. That has to be the product of electrolysis, and that can only happen if you produce a solid. So the reaction at the cathode has to be Ag+ plus electrons going to Ag, even though there may be some spontaneous reaction between Ag+ and tin. That cannot be what the question is trying to refer to. So in cell 1, what happened at the cathode is going to be Ag+ plus electrons going to Ag. This is going to happen at the cathode, which means that 0.34 gram must be the mass of silver being produced. So I'm going to Just write that down. M of Ag is 0.34 grams. Now, ultimately, I want to work out the mass of copper in cell 2. And I think I'm going to skip the steps here just because this video is getting way too long. But if you list everything present again, you have copper 2 plus SO4 2 minus and H2O. And you also have copper as both the cathode and the anode. So the reaction at the cathode, the reaction that's going to produce copper, it's going to be, so let's just divide that, cell 2. I'm going to have copper 2 plus Aq plus 2 electrons going to copper solid. That is going to be the reaction in cell 2. And the number of mole of electrons in cell 1 is going to be identical to the number of mole of electrons in cell 2. So if I have the mass of silver, I can find the number of mole of silver, which is mass divided by molar mass. And I'm just going to do it on the calculator here. And that is 0.00315 mole. And because of a 1-to-1 ratio, the number of mole of electrons is the same as the number of mole of silver, which is 0.00315 mole. Okay, and I'm going to use this number of mole of electrons to get to the number of mole of copper, which is going to be 1/2 n of electrons, or half the number of mole of electrons, which is a half of 0.00315. So divide that by 2, you get 0.00158 mole. And then from there, I'm going to find the mass. That's supposed to be as U times 63.5. I got 0. I'm looking at two significant figures, 10 grams. That's the final answer. So 1 mark for answer, 1 mark for finding the number of mole of copper from the number of mole of electrons, and 1 mark for finding the number of mole of electrons from the number of mole of silver, which means that a lot of people got 2 out of 3 even if they didn't recognize the correct product. And so I think a lot of people did get a lot of consequential marks. And then you have this question: copper sulfate solution has a distinct blue color due to the presence of copper 2 plus ions. The higher the concentration of copper 2 plus ions, the more intense the color. You need to compare the color of the solutions in cell 2 and 3 after current has been flowing for 1 hour. So if you want to compare the color of the solution between these two cells, you need to consider whether there is a change in the concentration of copper 2 plus ions in cell 2 and then in cell 3. So if you want to know whether there is a change in the concentration of copper 2 plus ions, you need to think about what is happening in these cells. So cell 2, I know that copper 2 plus is going to produce copper at the cathode. But alright, so ultimately I still had to do that. I'm just gonna go back and just highlight everything present. You have copper as both electrodes, so it's definitely going to be present at the anode. I have water present. I have copper 2 plus, if I can find it. Here we go. And I also have water here. So at the cathode, you have copper 2 plus going to copper because copper 2 plus is the strongest oxidizing agent. And at the anode, you also have copper being oxidized to copper 2 plus because it is the strongest reducing agent. So the reaction at the anode is going to be copper going to copper 2 plus and 2 electrons. So copper ions are being consumed at the cathode and produced at the anode by the same rate. So let's just write that down. Cu2 plus is consumed at the cathode. I really should have timed this. And produced at the anode at the same rate. So the concentration of copper 2 plus ion is unchanged, which means that the intensity of the color of the solution in cell 2 remains unchanged. Unchanged so as the color of the solution. So that's what happened with cell 1. Now, if we look at, cell 2. Now, if we do the same, if we look at cell 3, the main difference between cell 2 and cell 3 is that cell 3 doesn't have copper as the electrode. The electrode is actually graphite, which means that I need to, why do I do that first? I need to highlight again. I no longer have Cu, I only have Cu2 plus, and I have H2O. So at the cathode, the strongest oxidizing agent present is still copper 2 plus ions, which means that copper is still being produced from copper 2 plus at the cathode. So we're just gonna write the half equations again. So for cell 3, we have Cu2 plus 2 electrons going to Cu at the cathode, but at the anode, because there's no copper here, the only reducing agent present is water. So water is being oxidized into oxygen, 4H plus, and 4 electrons. So copper ions are being consumed, but they're not produced at the anode. So the concentration of copper ion would decrease as Cu2 plus are consumed but not reproduced. So just always think about the half equations. If you don't know what's happening in the cell, it's very hard to do any prediction, not reproduce. So if there's nothing else you can do, at least work out what's happening inside the cell. And okay, I think that's enough. You do have to compare the color. So the color, I can't spell, the intensity of color, seriously, that's ridiculous. The intensity of the color is more in cell 2 than in cell 3. Okay, that is it for question 2.